Hi everyone, so today we're going to be solving the week 8 physics AMS quiz. So this week it's really easy if you know the right rules to use. Okay, so here in front of us we have question 1. It's telling us that a group of students are investigating the law of moments and they put a uniform meter stick on a fulcrum that suspends two masses from it. The fulcrum is the center of the meter stick and mass 1 is 200 grams and it's located 30 centimeters away from the fulcrum. And mass 2 can be varied and suspended from different points along the meter, keeping it horizontal. And they told us definitely use G as 10 meters per second squared. So what I'm gonna do here is make mass 1 into kilograms. Wait, this is 1. Because it's easier for us to use. So it's gonna be 0.2 kilograms, if I'm not wrong, no? And 30 centimeters is gonna be 0.3 meters. So now we need to see, we know that they have two masses affecting and you want a balanced meter stick. Which way of the following will balance it? So what we do is we make sure that this moment is equal to this moment. So what we do is we calculate the how much this moment has to be or how much this moment is. We do this by doing mass 1. We do this by doing the moment law, which is weight times distance, because we know it's work times perpendicular distance. Work times perpendicular distance from last week, sorry. Is it work? Yeah, I think. So what you do is you do 0.2 times 0.3 times 10, which is your gravitational acceleration. So to find this, you do 0.2 times 0.3 times 10. You're gonna get it to be 0.6. Once you get 0.6, so you know this side is 0.6. So now you need to see what mass and what distance is gonna make this side 0.6. So all you have to do is see you see the mass, you see the distance, you multiply it by 10 and you will see. So 150 grams, which is 0.15 kilograms times 0.4 times 10. I'm gonna change the color because it's not that clear. So I'm gonna really quickly do them on my calculator. You're gonna get, yeah, so it's gonna be 0.6. So that's, since it's 0.6, if this is equal to this, you have the right answer. Now let's try again. 600, which is 0.6, times 0.1 times 10 is gonna be also equal to 0.6. Now when we do this one, it's gonna be 0.05 times 0.45 times 10. Just quick, you get the idea. So when you do this one, it's 0.05 times 0.45 times 10 equals 0.025, which is wrong. We need 0.6. Now let's see this one. It's gonna be 1.2 grams times 0.05 times 10. And if you're gonna ask why 10, because we need the weight. W equals mg. And mass is the mass, and the g is gravitational acceleration, which is 10. So when you do this, you're gonna get 0.6. And this, when you do it, let's see, 1.5 times 0.02 times 10, we're gonna get something differently different, which is, oh no, wait, I did something wrong. Yeah, you're gonna get 0.3 for this one. So 1.5 times 0.02, 2 times 10 equals 0.3. Okay, what was that? 0.3. That's supposed to be a 3, guys. I don't know what happened to my key. my pen. Anyways, so we can only choose the ones that are 0.6, which is this one, and this one. These two are wrong. Now let's go on to the next question. Okay, so which of the following characteristics form a couple? We know that couple forces are forces that are acting on the same body without a fulcrum in opposite directions with equal magnitudes. So I just said they have equal magnitudes. They are parallel. They have to be parallel. If they're not parallel, they're not a couple. They're in the same direction? No, they have to be in opposite directions, as we can see in this option. The moment of these forces forming the couple is zero. The forces forming the couple isn't zero. The magnitudes of both of them canceling each other out is zero, but the forces forming it are not zero. So next question. Okay, so here we have a couple question. So for a couple, any couple you see, you will take any one of these distances, forces. So we'll take 15, but they're both 15. So you'll take any one times the distance between them, but in meters. So 2 centimeters, which is 0.02 centimeters, is gonna give you times 15 is gonna give you 0.3, which is your answer, as you can see. This came last week. It was really easy. Now this question. Okay, these questions again, like I did for the first question, we're gonna have to calculate the magnitudes of each moment. So let's calculate this one's moment first. Wait, no. Let's calculate the moment for this one. So, oh, but they're. Wait, give me a minute. I'll be right back to solving. I just need to see what you calculate. Okay, yeah, sorry guys, I confused myself for a second. Anyway, so what you do is calculate this side first. So 25 centimeters, you're gonna make it into meters. 25 centimeters is 0.25, and you're gonna multiply it by the downward force times 50. When you do that, you're gonna get that this side's momentum is equal to 12.5. Now you need this side's momentum to also equal 12.5. So what you do is distance times newtons equals 12.5. So distance is 0.4 times newtons times question mark is going to give you 12.5. So when you divide 12.5 by 0.4, you should get 31.25 or something like that. X is going to equal 31.25, and just round it up to the closest number, which is 31. Now for part B, they're asking us upward force. So they want to know what's the force exerted by the fulcrum on the plank. To do this, you just add all the forces you have. So what you have to add is, of course, your two forces, 50 and 31, and you have to add the weight of the beam, because they never told us the beam is weightless. And they even gave us the weight of the beam. See, uniform plank of weight 20. So what you do, it's 20 plus 50 newtons plus 31. You're gonna get 101 when you add them. And that's it for this question. Next question. Okay, so again, they're asking you which one's a couple. We said couples are equal in magnitude, so 30 and 15 not equal. We said that there has to be two parallel forces. This does not even have two forces. This one, we said they have to be in opposite directions. We said they have to be parallel and not on the same line. They cannot be the same line. So this one's wrong, and this one's the only one that makes sense and is right. So next question. Okay, these questions, for the next few questions, it's easy. Whenever you see the point or which entire weight's body is to be concentrated, it's just center of gravity. Like if we have this plank and it's equal, nothing's affecting it, the center of gravity is going to be here. It's where all your force is gonna be exerted. Now next question. Okay, so when you have an irregular shape, you're supposed to do an entire like process for it that I'm gonna explain in one of the questions that is upcoming. And so yeah, just know whenever you have two intersecting lines from a lamina suspended, point zero would be your center of gravity. Memorize it like this whenever you see a shape like this with a center of two intersecting lines. Okay, so this question, we have a little law rule we have to use, a law. It's that our law states, wait, let me find it, that weight 1, I keep writing my ones as I don't ask, over weight 2 equals center of gravity 1 over center of gravity 2. Actually, guys, this law could be used, but it's gonna confuse you in this question, so I'm just gonna tell you the best way and easiest way to do it. So if the distance, so if you have him at a distance, just so again, calculate the forces. So you could calculate 0.8 meters times 60 times 10. You're gonna get 0.8 times 60 times 10. You're gonna get 480. So now you need to make this equal to 480. So you have distance x, which we don't know, times 10 times 40 kilograms is gonna equal 480. So once you do this, it's gonna be, wait. You're gonna get your x to be 1.2. And that is it. This question is way easier when you solve it like this. Okay, so now we have another question. It tells us we have a massless seesaw. Keep this in mind. It has no mass. Of length 100 centimeters, and that has two people of masses 40 and 60 sitting on opposite ends. So you have a seesaw, and you have here a mass of 40 kilograms, and here you have a mass of 60 kilograms. Now they're asking you what's the distance away from the 40 where it's the center of gravity. So what you do here is the law I was telling you about, which is weight 1 over weight 2 equals distance between wait, it's this gg2 over gg1. This is the center of gravity 1 and center of gravity 2. So here what you have to do practically is just, you're gonna do weight 1, we calculated, is 40 kilograms. Wait, so it's 40 over 60 kilograms, which is, here you don't have to actually calculate weight because you're taking a ratio. You could just take the ratio of the masses. So you're gonna take your ratio that's gonna equal to 2 over 3, and you're gonna find it with the centers of gravity. So you're gonna have to multiply this ratio by your entire length, which is 100. I think that's like what I did. Wait, I probably could be. Wait, no, wait. What did I do? You don't multiply it by 100. Sorry, guys. So you just take your ratio, which your ratio should be 2 over 3 once you simplify this. And then you. Okay, yeah. So, sorry, this is your ratio. So, when you add these two ratios, you're gonna end up with 100. So we need to find these two ratios are equal to your distances, which is gg2 and gg1. These are your distances, but now you don't have any of these, so we need to find the ratio. So it's 2x plus 3x. They're all gonna equal 100 because we know that they're the ratio you're gonna find of these. So it's 5x equals 100. So x is gonna equal to 20. Since x equals to 20, now we can find the distance. So we know that GG2 is gonna be GG2, which is definitely like the one sitting away um from the 40 kilogram person. It's that the ratio is 3 over 2. So since this is the ratio of weight 1 over weight 2, then the ratio of GG2 over GG1 is 3 over 2. Of course, since you're flipping them, 1, 2, 2, 1, 3 over 2. So now we know that your x is 20 for the distance. So if you have away from the 40 kilogram person, your ratio is gonna be 40 kilogram person has GG1. We have 40 kilogram person is person 1. This one is person 2. So GG1, which is distance, is 20 times his ratio, which is, wait, I mixed something up here. Our ratio is 20, and 20 times, yeah. Sorry, it's not GG1. It's, the ratio is 2 over 3. You don't flip it. And GG person 1 is gonna be 3 times 20. So 20 times 3, and his distance away is gonna be 60. And the force exerted by the fulcrum, oh wait, sorry, what did I do? Yeah. So his distance away from the fulcrum is gonna be it's gonna be, what's it called? You have to find the weight of both these people and add them. Since it's a massless seesaw, we don't add the seesaw like we did in the previous question. So you have 40 and 60. 40 times 10. So this person's weight is 400. Guys, wait, because my tablet disconnected from my laptop, so I don't know. My handwriting is bad. Let me just reconnect it really quick. And I'll be right back. Don't technical issues. Okay, yeah, guys, so I'm back now. So we have 40 times 10, and we have 60 times 10, which is 600. So 400 plus 600, you're gonna get your total force exerted, which is 1,000. If this seesaw had a mass, it wouldn't be 1,000, it would be something different. So if it had a mass, you would add the mass, but since it's massless, you don't add the mass for it. This question, I'm gonna come back to it at the end since I probably mixed up the people watching. Okay, this question is easy. So this question, first you have to find the slope of the graph. We know to find the slope, you'll do this, divide by this, but at any point. 0.15 divided by 0.1 is 1.5. That's all you do here. Now, we know that the slope is giving you a ratio. Since it's giving you a ratio, and you know that this is your ratio between these two, this is the weight that keeps it balanced, this is the ratio. So if you have this as 2 and this as W, you need to multiply the 2 by the ratio to get W, since this is the ratio that keeps it balanced. And this is the mass that you want to balance with. So 2 times 1.5 is 3. And that's how you solve it. It's really easy, this one. Now let's go to next question. This is the question I'm telling you about. So for here, you have to abide by the steps of solving for in an irregular object. So first, we're gonna start off. You memorize these steps. You're gonna suspend it from, like, let's say we have this object and we're trying to find its center of gravity and whatever. You will have to first suspend it from a fixed point and let it settle. Then you will use a plumb line and draw a vertical line where its suspension is down, always down, to the center of gravity. You're always doing it down because gravity is down. And then when you keep getting your points, you're gonna, whenever you suspend it differently, you're gonna keep getting different lines, and that center where they all intersect, that is your center of gravity. So just, and then you're gonna keep repeating this to like make sure of your actual, like if it actually is. So that's it for this one. Memorize it is the best way to get it right. Now we have question 12. Okay, so this question you have two different ways of solving it. I find one of the ways easier than the other, so I'm gonna solve it by the way I find easier. Maybe later on tonight I'm gonna post the other way, which is in case people didn't understand the first way. So we know that when you have a falcon, you have the clockwise moments equals counterclockwise moments. So what we need to do is, wait, let me read over my notes because I mixed up the question and I lost it. Okay, yeah, guys, I'm so sorry. I found it finally. Anyways, so we know that we have counterclockwise moments equals clockwise moments. So we need to find distance x. So we first have to calculate all our clockwise moments and all our counterclockwise moments. These are wait, so yeah. You put your hand in the direction of the force. These are clockwise moments. T and W are clockwise and N is counterclockwise. So force, so let's do it now. T, which is the force times, or into X, which is our distance, because we need the moments, which is force times distance X time plus weight times 50, which is, I'll tell you where we get the 50. Let me write it down, times 50. So where we got the 50 from, we said this is a uniform meter ruler. 1 meter, half of it is 50 centimeters. So half of a meter is 50 centimeters. Equals the counterclockwise moments, which is N. N into our distance, which is 45. Now let's substitute the values we know, which are T, W, and N. So tension is 0.48, because we know tension is weight and weight is mass times gravitational acceleration. So we have a mass of 0.48 grams, so it's 0.048 kilograms, and times that by 10 for the weight, which is gravitational acceleration. You're gonna get T to be 0.48 times X. X is what we're trying to find, so we don't know it. Plus W. What's W? W is our weight of the ruler, the whole ruler, which is 0.95. So plus 0.95 times 50 equals to N. Now we know that T and W are going down, and N is the resistant force. It's the normal. The normal, so N equals T plus W. So you do 0.48 plus 0.95, you're gonna get N, which is equal to 1.43 times the distance, which is 45 centimeters. And by the way, you don't change centimeters to meters here because they want the answer in centimeters. So now what we do again really quickly is now we have to actually multiply our values. Let me just, I don't know if I can move this up a bit. So yeah, I'll give myself more space. So now we're gonna solve. So 0.48x plus 0.95 times 50 is 47.5 equals, we solve this to and find out it's 64.35, and then we get 0.48x. You're gonna move this to the side, equals 1000, wait, no, sorry, 16.85. I don't know where I got 1000. 16.85. And we find out that x is equal about 35.1, but we're gonna round it up to the whole nearest whole number, which is 35. So really quickly, what we did again was clockwise moments equals counterclockwise moments. And our clockwise moments, which are t and g, are t, which is the force t times weight, force w, each times their distance for the moment, equals the normal, which is opposite to it and counterclockwise. By the way, if you want to know if it's clockwise or counterclockwise, you do right hand rule. So then we substitute. T is 0.48. We know this because we need to calculate it. They told us its mass. You make its mass in kilograms, multiply it by 10. There you have its weight, which is 0.45. This, they gave it to us given directly. You don't multiply it by anything. 0.95 times the distance 50 gives you the sum of t and w, because this is the normal. Normal always resists these two, so it's the sum of these two. It's going to cancel them out, so it has to be equal to the sum of these two. So 0.43 times 45, and then you're going to get 0.48 plus 47.5 equals 64.35. You're going to move this to the side, and you're going to solve 0.48x equals 16.85, all in your calculator. 0x equals 35. So this is how you solve this question. It's really easy when you actually focus on the given. Okay, so this next question, it's really easy. So a boy uses a spanner, which is like a wrench, you could say, or like a tool. It's a tool used in, I can't really like explain it. It's a tool. So a boy uses a spanner of length 24 to tighten centimeters to tighten the nut. And the moment if he does a right angle to the spanner with a force of 15 newtons is, so we know that this is the perpendicular distance. If it's, so let's say this is the thing he's doing, and his force is going perpendicular to it. So this would be your distance, which is 24 centimeters, and you have a force of 15 newtons. So we're gonna make this, into meters. So 0.24. I'm convinced it's 25. I don't know why. Times 50. Put it in your calculator. It's 12. You're gonna get 12. Now, if the angle between his arms and the spanner increases from 90 to 120, the moment of his pull to one decimal point. Now, what we have to do here is we have to find the horizontal angle and do cosine times force times distance. So cosine angle times force times distance. I don't know if you remember this rule to find the moment. So what here we won't find the distance, the horizontal distance, because it's more than 90. So what we do is we change it from cosine to sine. 120, which is your angle, times the force 50 times 0.24. Really quickly, I'm gonna do it in my calculator. Sine 120. 124. You're gonna get what you round up to 10.4 when you do it. So when it's an angle that you know it's not with the horizontal, because it's more than 9, like you can't tell if it's with the horizontal or not, so it's with the vertical. This one's with the vertical. Because see, you increased it from a 90-degree angle to a 120-degree angle. So that's with the vertical, that's not with the horizontal anymore. So it's either you find the horizontal, which is this, and do cosine of, wait, what's it gonna be if this is, here it's 120, so this is gonna be 60. So you could do cosine 60. Let me just try it really quick because I know I didn't try it yet. I usually do it sine times 50 times. Yeah, don't do cosine 60. I messed up the angles. Just do sine 120 times 50 times 0.24 and you're gonna get the right answer. And you know that this increasing the angle decreases the moment. The closer you are to 90, the better. The closer to 90, the more the moment. Now we have our last question. This question, we also have to do counterclockwise and clockwise moments. So the distance from the hinge the man can move. Okay, sorry. So they want the distance from the hinge that the man can move before you break the cable. And you have a man of mass 90 and a uniform beam of mass 80. And the beam is hinged at A and hung at B, and its capable maximum load is 1000 newtons. So if our capable load is 1000 newtons, we have to find the moment of it, this moment. So it's going to be 1000 times the distance. So 6000, so it's 1000 times 6 equals 6000. Then, once you find this moment, you need to find the other moments, which are your counterclock. Wait, this one is, your Falcom is there, so this one is your clockwise moment. Now you need to find your counterclockwise moments. So 6000 is, wait, 6000 is the sum of moments or whatever. So it's equal to your 90 kilogram man's weight. So 900, since 90 times 100 is 900. Sorry, times 10, because gravitational acceleration for weight. 90 times the distance. We don't know your distance yet. We want to find the distance that he can move before he breaks the cable. So times x, which is distance can move, plus, it's meant to be plus. Sorry about that. So plus the uniform beam's weight. So it's 800, and the distance of your uniform beam is whatever is here, like this distance here. So this is 3 meters. If this is 6, this is 3. So you do 800 times 3, you're gonna get 2400. Once you get 2400, you're subtracting it from 6000. So 6,000 divide minus 2400, you're gonna get 3600. So you're gonna be left with 900x equals 3600, and x equals 24. And that's how you solve this question. So again, what we did is we found we found the clockwise and the counterclockwise distances, and we added them. Magnitude, sorry. So the tension is gonna make a magnitude moment of 6000, and your man, he's gonna make a moment of his weight times a distance. We don't know this distance yet. We need to know what distance can he move from point A until the cord breaks. So we're gonna put the distance as x, since we don't know it. And you add it to the moment of the center of gravity of this beam. So since the center it's equally cut into 3 and 3, and you can say that the center is somewhere here where the man is now standing. So you do 800, which is the weight, times the distance 3, you get 2400. Then when you substitute it, you're gonna get this, and then x equals 4. Really quickly, I'm gonna go over back to question 9 because I feel like I mixed you guys up in it. So again, rule weight 1 over weight 2. GG2 over GG1. We don't care really much about this. Don't care about it. We will look at weight 1 and weight 2. So if you have a person of 40 and you have a person of 60, your ratio is 2 to 3. Since our ratio is 2 to 3, we know that this all, when you add them, they're gonna equal to 100 centimeters. Since they want it in centimeter to make this meter. So 2x plus 3x is gonna equal to 100. 5x, 100. X, 20. Since this is now your ratio number, you're gonna take your ratios 2 and 3 and multiply them by 20. So by times 20 times 20. And since they're switched for here, G2 and G1, you're gonna flip it 3 over 2 times 20 times 20. First flip it, then do times 20, guys, okay? This is your ratio for the weights, and then you invert it for whatever the distance is. So we know that here we had the 40 and here we had the 60. So it remains, if 40 is on top, whatever you do here is for 40. So it's 60, and the distance from 60 kilograms is 40. And that's how you just solve it. You have to find your ratios. And after that, I think we're done the entire quiz. Hope you understood everything. If you don't understand anything, write it down in the comments. I'll make a video re-explaining that specific question. And bye!